Awesome. Well, hi, everybody. Welcome to our project night. We're going to run through some slides real quick to intro Women Who Code and the track, and then we'll get right down to business for what you guys came for. So let's go. The mission of Women Who Code is it's all about inspiring women to excel in technology careers. So if you're in technology already, we want to help by providing resources and support, and that's what our main focus is. Um, Again, what our goals are to empower women with skills needed for professional achievement, educate companies to better promote, retain, and hire talented women, build a global community where networking and mentorship is valued, and develop role models and support this generation of engineers. Women Who Code does have a code of conduct that its members are expected to follow. So if you feel like something's not right, you can go online and submit a report. Basically, anyone who supports our mission of helping women excel in technology careers is welcome. So with Women Who Code, you get quite a few benefits. For example, we have some coding resources vault that you guys have access to, along with a job board. If you follow along our weekly newsletter, you'll see our scholarships and our ticket giveaways. We're a global community, so we're across the world. You can also apply for joining a leadership position within Women Who Code. The Python track is looking for people to fill that role or join the leadership team. So email us, reach out, or stay after the chat to find out more. And then last but not least, we have our awesome Applaud Her. I'm not sure what to call it, action, I guess. I don't know. And what it's about is when you see someone who does a good job, you get the chance to promote their hard work. So it's just kind of shining light on those who might not shine it for themselves. Women Who Code launched 6 different track communities this year. Python was started in April, so we're a few months in. We're still in the baby stages of our community, so help us grow. If you can, that'd be great. We are, like I said, one of 6, so you can see the other 5 here. If you're interested in learning more about those, you can go to womenwhocode.com / and then just add on the track name that you're interested in. And then, of course, we couldn't be here without our sponsors. So thank you, McKinsey & Company. Thank you, Python Software Foundation. Thank you, the Home Depot. It really shows how important these track communities are through your sponsorship. We appreciate it. To touch on our leadership team a little bit, we've grown to 5. If you want to see your face up here, just email us and we can start a conversation around that. These are the different ways you can get involved with the community outside of just being a member. You can join as a lead or join as that word, evangelist.
Evangelist.
Yeah. So anyone who is really good at social media, we need you desperately. So let me know. Thanks so much. Speaking of social media, join the conversation. So we definitely are here. The reason that our community is here is to provide the resources and the content for women who wouldn't actually have it through the local chapters because maybe they couldn't get to a meetup or whatever the reason is. So join the conversation, grow our community, and share these resources with whoever and you think would benefit from them. We have a track summit coming up at the end or at the beginning of November. It's going to be in Atlanta, November 2nd, and hope to see you guys there. And that's all we have information on that, so stay tuned for more. And that brings us to why we're here. So huge shout out to Bethany for taking time out of her day to spend it with us with a hands-on project. So without further ado, I'm going to pass it over to Bethany.
Okay. My part of this is going to be considerably looser. I want this to be a discussion and to be participatory and not to be me just talking and presenting slides, because I think the best way to learn this stuff is just to get in there and to ask questions and to pull things apart and to try things. Also, this is kind of my first time doing a project night kind of online and not around a table with people kind of physically present. So I would love to hear feedback and suggestions and thoughts about how we could make this better for you and make this helpful for you both with topics and with the way we present stuff and the way we discuss stuff. So basically what I did for this is and let me share this with you, hold on. Okay, so let's see if I can find this. Hello. Well, why is this not working? Okay, there we go. Can you see my screen?
Yes.
Shout out if you can see my screen. Okay, so ultimately what we're going to end up with, and it may not be at the end of this session today, is this little tic-tac-toe game. And I'm going to show you online at a place called Trinket.io, which you can also get a copy of. Let me send this in the session if I can. Oh no. Okay, so how do I send it in the session?
There's a chat at the very bottom. If you want to click that, you can send a link. Is that what you're trying to do?
I am trying to send a link, but somehow it's not letting me share. So let me do that first. Okay. Why am I not being able to do this? Oh, good Lord.
Nothing like a live demo, right?
Exactly. At least I'm not coding live. You guys could see my glorious ability to code, which is pretty funny live. Okay, so there is a link to the Trinket. So that Trinket should enable you to play with the code in your browser as opposed to on your desktop. But the other thing that we can do is also give you a link to our fabulous repo that will give you all of the code and the exercises for this. So there is the updated repo as well. Okay, so let me go back to sharing my screen. If I can manage this, bear with me, people. This is scary. Okay. I'll put my editor on the other screen so that I don't lose it again. Okay, one last time, people. All right, can we see this?
Yes.
Okay, great. So this little GUI will allow you to play tic-tac-toe against the computer. I'm going to pick O. The computer's going to go first, which probably means the computer's going to win, if you know the odds of tic-tac-toe. Every once in a while, I get lucky and win. Nah, no love here. But then it asks if you want to play again. And then you can do it all over again until, let me lose on purpose here. Oh, come on, don't make it that easy, computer. All right. Well, I'll win, never mind. And then if you click no, it says thank you for playing. And then you're done. And so I thought what we would do is break down how we get to this point by going through how you do this on the command line and all the little pieces that go together into this program. But first, before I go into that, I think I'd like to know a little bit more about the people who are participating and kind of what level you're at and what you kind of want to do with Python. If we could do that really quick. Hello, hello. All right, well, this is the point where I say to people that if I am going too fast, if there is something that you don't understand, if there's something you want clarification on, I don't have a specific case for this. My whole strategy for this project was to have as much information for you as possible in that GitHub repo, and to let you kind of explore that and ask the questions you need to understand the concepts. And I don't think anyone expects you to get all of this in one gulp, or all of this in an hour and a half. Just to share with you all, it took me probably 3 weeks to put together all of this material. And for the two programs that I did for this, the command line and this one with the GUI, I think it took me probably a good 4 days. And I'm not a newbie programmer, but these things, this is why TicTacToe is not a kid's game. When you start breaking things down when you program, it is not an easy thing. In fact, I think the hardest thing to do in programming is to really understand the problem that you're trying to solve, the thing that you're trying to do, and then break it down into the sequential steps that the computer needs, because the computer's dumb. And so you have to break it down into pieces that the computer can execute. And for me, even after all of this time programming, that is still the hardest part for me, is to really think about what I want to be doing and what is the sequential process for doing it. And so, yeah, it took me quite a while to put this together. So even though this is a beginner project, it has a lot of the same components that a much more complicated project or a bigger project might have. It just is a little bit shorter, and it's focused around tic-tac-toe because that's a game a lot of people at least, know how to play, and the rules are pretty well understood for it. So I think I'm just going to launch into some things, and I really want people to interrupt me with questions and stop me if you aren't understanding something, or you want to just spend some time on some of the warm-up exercises. We don't have to get to actually coding this program today. We can just talk about all the pieces that make it up. So there we have it. Okay, let me know, give a shout if you cannot see my screen. I am going to open up the repo where I have the code and the warm-up exercises. All right, I'll pull it up on the screen in just a sec. I just want to make sure I can actually get to the repo. Because, hello, I'm cursed today. Okay. All right, so this is the repo, and you can get to this repo by clicking that link that I put into chat. And then under that link, there should be a little line that says, hold on, let me grab it. Oh, nothing is cooperating with me today. Okay. Best laid plans, people. All right, so if you go to the line that says beginner nights and you click on that, that should take you to a page that has 2 entries. One is for a spirograph and one is for tic-tac-toe. And you want to click on the one that is tic-tac-toe. And when you do, you should see this. And this is filled with all sorts of links and resources that you can refer back to. This is all the different components and different skills that you would want to use in doing this program. So there are things like the data structures, which are things like tuples and dictionaries and lists. And this is a little explanation here about data structures themselves. So in the Python programming language, you have things like numbers and strings that you can use to represent data. And you have things like variables to name that data. And then when you combine that data into a more complicated structure, that is then what we call a data structure. So a list of strings or a list of numbers, or this weird thing called a tuple, which is kind of like a list, or a dictionary that organizes information with a key, like a name, and then values, which is the data that you're storing. So that's kind of a little quick explanation of what a data structure is. And Python has a lot of these. They're really useful. There's all sorts of flavors of dictionaries. There's all sorts of ways to play with lists, which we'll do in some warm-up exercises here in a second, and all sorts of stuff. And then there's things like looping, going through every item on a list, or going through a certain number of actions a certain number of times. Then there's things like event loops, which is a little bit more kind of out there. An event loop is the thing that you saw where the game will ask you if you want to play again. And as long as you answer yes, the game will start over at the top and repeat all the steps. And it will continue to do that until you tell it no, and then it will exit. So it's kind of a really, really big loop for a program that will just continue to go around and around until it's told to stop. There's things like input. You'll see that in the command line version of the program. That is the computer asking you for something on the command line, whether it's to answer yes or no, or to type something in. And then there's, of course, things like functions, and functions are the way you organize code. It's a little block, something that does something, code that does something that you name. And so you can define a function, name it, you know, say hello, and then every time you call that function, it executes the code. There's things called conditional logic. If something is true, do the following. If something is false, do something else. Ternary expressions, which are a way of shortening that if-else logic. Various ways of formatting strings. Global variables. The Python turtle module, which is that little thing that draws pictures on the screen. And then there's just links to the docs. So I'm going to pause here. Does anyone have any questions or kind of any comments? Should I be just kind of slowing down and going over basics, or would you rather have me plow through this whole program and kind of describe things to you?
Hey, Bethany, there was more of a general question in the chat by Morgan. Yep. It regarded IDEs. Mm-hmm. Is there anything that you've used that you enjoy over others, or ones you would recommend?
Well, okay. So you'll find that I do this a lot. My answer is it depends. So PyCharm, at least in the area that I live in the San Francisco Bay Area, PyCharm is considered the IDE for professionals. I don't know what that means really, except that PyCharm is spendy. So for the professional edition of PyCharm, it will cost you initially about $200. And then to renew that license, I think the second year is $99, and it might go down as low as $89. So if you are at a university, oftentimes you can get a student edition that will then roll over the license. But you don't necessarily need everything that PyCharm gives you. There are some really, really nice tools in PyCharm. There's a way for you to manage this thing called Docker. So Docker containers, virtual environments, which is something kind of down the road to help you organize projects. It has some really nice syntax highlighting. It has really nice plugins if you want to do web development for things like Django. Because when you're doing a website using Django, which is a web framework for Python, you have to write HTML in combination with Python. So there's these template tags that you use where you put Python code inside the HTML. And unless you have a plugin, that syntax highlighting gets really, really screwed up. So anyway, so there's a lot of things that are really, and there's Git integration, there's GitHub integration. So there's a lot of really cushy features in PyCharm, but PyCharm comes with a price tag. So there is Sublime. Sublime also has a lot of those same plugins that PyCharm has. Some people think Sublime has kind of aged a little bit because it's an older IDE. I think that that is perfectly nice, and I did use that a few years ago. The other thing that's really cool about Sublime, when people say, oh, Python is slow or Python is just quote unquote a scripting language. Well, Sublime, which is a desktop application that is stable in production that people pay for, is written in Python. And it actually has a really nice, interface and all of that sort of thing. Sublime, I think, is $50. So again, it's not free. I do think that it is a nice editor. You do have to configure it a bit. So that is one of the trade-offs. If you are kind of brand new to coding and brand new to things like understanding what syntax highlighting does, something like PyCharm is nice because the defaults are kind of set up for you. And there is a community edition of PyCharm. It's just that the community edition doesn't support web development and it doesn't support Docker containers. So you want to keep that in mind. Sorry, I'm taking too long with this. But so Sublime is okay. And then there's the two newer IDEs, Atom, which is made by GitHub, and Visual Studio Code, which is technically also made by GitHub at this point because Microsoft owns GitHub. So Visual Studio Code is Microsoft. It's beautiful, and it's a quite nice IDE, but again, it has the same kind of downside as Sublime does, which is that if you're just starting out, you don't know what you need, and in order for it to work, you have to put together a list of Python plugins, plugins for Python to make it work, because it's kind of more of a text editor. So you have to do things like install syntax highlighting and other things like that. What's really cool about Visual Studio Code is that it has this feature that allows you to launch collaborative sessions. So if I have Visual Studio Code and someone else does, then you can pull up your code, call the other person up, and the two of you can set up a tunnel where you can work on the code together. So that's kind of a cool feature. Atom also has that feature. And in fact, Visual Studio Code and Atom are kind of head-to-head with their features. They use the same plugins. They use the same syntax highlighters. They're actually written in the same framework. Unfortunately, which is what many people feared, is that now that GitHub is owned by Microsoft, Visual Studio Code is getting more love than Atom, and Atom is not stable. So I have crashed Atom on occasion. And to make this really long, rambling explanation a little shorter, Morgan, I'm sorry. These days, I use PyCharm, but I have installed all of the other ones. So unfortunately, I'm one of those people. I have all of the code editors, and I tend to use different ones for different purposes. So if I'm collaborating with someone and I need to really work intensively with them on the code, I might actually fire up Visual Studio Code because it allows me to collaborate really easily. PyCharm doesn't have that feature. If I need to do data science and I'm doing a lot of inline graphing, I might actually use something called Spider, which is an open source IDE, because PyCharm will graph, but it does not graph inline, and it's just the way it's set up. I think they're trying really hard to make it work for data science, but it's really not a great IDE for like the inline graphing and doing Jupyter notebooks. It crashes your computer if you open up too many notebooks, different things like that. It really isn't, PyCharm is really an IDE that was designed for programmers who are writing code for big applications and not data science, whereas Spider was kind of designed with the thought that people were going to use it for data science. So there's some trade-offs there. I don't know what else I can say. I'm sorry. I've spent a lot of time talking about IDEs, but IDEs are important. I often tell people when they first start, when you first start, all you really need is the IDE that's built into Python, which is called idle, because it has syntax highlighting. It allows you to write programs. You can write programs with a text pad. But as you start to get more complicated in your programs, when you start to want to do things like write tests, it helps to have things like syntax highlighting, linting, which is, linting is a type of thing where the IDE will tell you if you got the syntax wrong and will like highlight your errors. It's like spell checking for code. And so those things become really nice as your programs get more complicated. You know, and then also if you end up joining a team that is using a particular IDE, sometimes it helps to use the same one just because then you might even be able to borrow a teammate's settings for that IDE so that you can kind of follow all of the same rules that your team does. So yeah, it just depends. All right, let's see. It says, I enjoy using Atom. When I first got started, I was using PyCharm. Yeah, I have to tell you that I like PyCharm now, but for the first 6 weeks that I used it, no one wanted to talk to me because all I would do was whine and complain about it because there was a learning curve for me. So that's the other thing, is that I tend to shy away from strongly recommending any code editor IDE for people because it's a really personal thing and it's about how you personally work. And so if you're going to be spending like 8 hours a day staring at your screen, you better enjoy like the colors and the features and the hotkeys that you're using, or you're going to be sad. So, oh, I'm sorry. My second screen just died on me. I need to reboot it here really quick. So now all my chat windows are now in one. Apologies. There we go. All right. Oh, awesome. Yeah, Morgan, go ahead and check out Visual Studio Code. I'm sorry, I'm just kind of catching up on the chat window. It's free, which for me is the right price. I think that's why I ended up with so many IDEs on my machine. PyCharm's the only one I paid for Sublime, and Sublime is not too expensive. But PyCharm is the one I really shelled out for. And the jury's still out for me on whether or not, I don't know. I still switch back and forth. I use Visual Studio Code these days more for, I also program in Go. And I really like the tool integration that Visual Studio has with the Go toolchain. So I use Visual Studio Code for Go. I use PyCharm for Python and for Python in Django. I've kind of gotten addicted, I have to confess, to WebStorm, which is another JetBrains product. And the license that I bought for PyCharm allows me to use WebStorm as well. And I use WebStorm for JavaScript and for React. It has really, really nice syntax highlighting. Let's see if I have, yeah, so this is my WebStorm. In fact, this is a JavaScript program that I happen to have open. You know, and so it has kind of nice syntax highlighting for that. Atom, believe it or not, I use for Markdown. It has a nice Markdown previewer, which is terrible. I should be using it for coding, but I'm actually using it for note-taking at this point. So, alrighty. Any other questions? that I can answer generally about that sort of stuff. Nope. Okay. Let me go over this the code files really quick. So what I did here is I was trying to kind of show a little bit of my thought process as I went through this. So to start, there's this stub file. And the stub file kind of lists out, I don't know if you can see that, or you can kind of follow along the repo. This lists out all of the functions that I thought I needed for this. And so one of the general rules when you're doing a program like this, the temptation, and the first time that I went through this TicTacToe program, which I didn't save in here because of course I was trying to be pretty and show best examples, but I kind of got in there and wrote this whole monolithic kind of 500 lines of code at a go. The problem is that gets really, really ugly, really, really fast. And it's really hard to figure out what pieces of code interact with other pieces. So one of the best practices that you can do in a project is to get things down to the smallest logical units that work and that could potentially be reusable. That's kind of the general rule for functions. And then you want to call them, because it's Python and because also, I don't know about you all, but my brain just is too full of things. So I always try to name my functions things that make sense. So functions do things or return things. So I try to name them that way. So like, here's a function about drawing the tic-tac-toe board, right? Here's a function about a player inputting their choice of X or O. Here's one about the first move, and so on. And so here, you can see here's one that copies the board, although that was probably a little too much. You know, checks to see if there's space free, chooses a random move. There's this whole little AI piece in here about the computer moving to block you and the rules about that. And then there is a main game loop. And remember, I talked about event loops briefly. If you notice here, we've got this thing called a while loop, which we can dive into in a little bit. But here, as long as true, meaning because there's nothing that sets this to false, basically it's just going to run forever. It's going to run forever until you break, until this condition here. So as long as somebody answers yes to play again, it's just going to continue the loop, right? And so loop, 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 endless, endless, endless. So that's the stub file. And that's me kind of thinking about like, what do I need? And you know, this is not something that you necessarily do up front. Sometimes you do. If you really understand the requirements that you're going after, you might be able to go and this is called stubbing, so stub it out. But more often than not, what happens is you write a bunch of code and then you're like, oh, wait a minute, I'm lost. And then you go back and like, okay, I can pull this piece out. Can I pull this piece out? And you start pulling different pieces out and naming those and pulling them off into functions. So don't feel like when you go to sit down to write a program that you have to think of all of this up front. You don't. You usually arrive at this. You back into it. So if you are, you know, if you want to take a shot at doing this from scratch, and I highly encourage you to do so, you might want to start with something like this, or you might want to start with a much shorter list than I did. It kind of depends on you and what you think you need. Like, it was a little extreme for me to like pull out a first move and, you know, to pull out a copy function for the board. I mean, Python has a really easy copy function. You just call copy. So you kind of don't really need to make a function that copies. So different things like that. All right, so the next step in this process then is that I just kind of went for it. So here's my first pass in all of its glory. And I imported a little library called Random. Random is part of the core Python library. So it's not an outside library. It's what you get when you install Python. It's just, it's not something that is immediately available like on the command line if you launch the Python interpreter. You have to import it. So that's what I'm doing here. And one of the things that Random will allow you to do is it'll allow you to choose something from a list at random, or it'll give you a random number, or there's all these things related to, and it's not truly random, but to pseudo-random numbers, pseudo-random choices, different things like that. That's basically it for the command line version of this program. And let me see if I could pull up the code on my machine, and I'll run this in, if people can see my screen, I'll run this in my command line prompt. Or maybe I won't. Let's see, let me pull PyCharm down here. All right, bear with me. You might not be able to see this on the command line right away. Nope, this is not going to, no such file or directory. No, that's not the one I want, PyCharm. So this is a little bit annoying. Okay, you know what? I'm not going to do this. I will do this on my command line and not through PyCharm. So Morgan, to answer your question, this is one of the downsides of PyCharm. So right now, I set this configuration for my PyCharm to be this really specific thing where I pull up a window because I was doing Turtle. And so now in order for me to just run the command line script, I have to redo this configuration, and I am over it. So instead I'm gonna pull up a terminal window. Bear with me for a moment. Yeah, maybe not that terminal window. Oh goodness, Bethany, what the hell did you do with your terminal window? All right, screw it. I'll open a brand new one. Okay. Oh, no such file or directory. What? Open 373. Open app maxo. Okay, so. Kiddies, don't try this at home. So, okay. Let me. I'll explain this. Oh, there goes my monitor again. Well, I think that the gremlins are truly testing me today. All right, there we go. I will explain this in a minute, but I essentially on my computer use a bunch of virtual environments to organize different projects and keep different projects from conflicting with one another. And I use a distribution of Python called the Anaconda distribution. And it has this package manager named Conda. And this is just essentially a list of all the environments that, quote unquote, that I've made. But what this really is a set of folders that are named. And each folder has a Python version and all of the libraries needed for that project. So for some of these, like this Pi36 NLP starter here, that particular folder, that particular environment has Python 3.6, and it has NLTK, which is a library used for processing language. And it has like NumPy and SciPy and different things like that. But its version of Python is tagged to Python 3.6. Whereas like this one is basic 3.7. That particular one has an installation of Python 3.7 and nothing else. It doesn't have any other libraries. Whereas like down here, you can see this one has Django. And so this one has like a web server. This one has all the support for the Django web framework, because that's essentially an environment I use to work on websites. So that's what this different stuff is. And you don't need to worry about this when you're starting out. This is something that you do when you become an insane person like me, where you have one too many projects and are doing too many things at once and like to make messes. So let me just activate an environment here because my main version of Python appears to be, as we'd like to put it, borked. So I'm going to have to do this inside of a virtual environment. Okay, so, and if you're still with me, you're brave people. Okay, so let's see if we can run this at the command line. Okay, so here we go. I don't know if you can see this or not. My screen may not be big enough, but it's asking me if I want to be an X or an O. And I'm feeling like I want to be an X. And so then it draws a little screen here. And it would appear that, no, okay, my math was okay. Yeah, it is actually drawing a grid of sorts. And so this one asks you have to type in the number of the square for the move, and then it reprints the board each time. So this one has a little bit different flow from what ends up being the GUI, because in the GUI, we're not redrawing the board each time, we're only drawing the X or the O. But on the command line, we have no choice but to kind of print out the board all over again. So the computer's chosen square number 9, so I'm going to choose square number 5. And somehow the computer has beaten me, which makes me think there was a logic problem in there that I missed, because all of a sudden the computer has moved 3 times. Okay. Well, we're going to have to debug that at some point. Okay, so thank you for playing. So essentially, that was this first pass. And as you can see, we've got a lot of code here. All right, you have a question, Morgan, about my functions. You always define self as the first parameter in a function and then give the other parameters as arguments. Yes, there's a very good reason self is not used here. Self should not be used in functions unless those functions are part of a class. So classes are a little much to explain all in one go here, but it sounds like in the course that you're taking that they're teaching you object-oriented programming, and classes are basically a way of, they're blueprints for objects. And so the functions that are associated with an object or with a class. We usually call those methods. And if you want those methods to work with an instance of an object that is made from a class, then you need to use the self keyword to let the Python interpreter know that that function belongs with that class and that that function is intended to be used with an instance of that class. But if you are doing what I'm doing here, which is letting the functions hang, then you do not need self. So Python has this kind of magic that happens. Python is an object-oriented language, but Python allows you to have this global environment that will let you define functions, variables, and do other actions and not tie them to a class. That makes it quite different from the way Java does things, if anyone is familiar with the Java programming language, because Java requires that you always tie your functions to a class. Python does not require that. And so here, if you notice, there is no, if there was a class, I would be defining it, say, on line 8 here in my program. It would be like class TicTacToe. And then all of these function definitions would be under it, and they would require self as the first parameter. So that the Python interpreter knew that it belonged to the TicTacToe class and that they operated on instances of TicTacToe. So that's essentially it. And you also see the self keyword when you use classes. Self is used to define data that also belongs to an object. So let me see if I can pull up a quick small example, because the visual is probably better here. By the way, if none of you have been to this site, this is an excellent place to do small practice problems. It's called Exercism. And what I personally really like about it, my friends are all sick of me talking about it. They think that, I don't know, that I am being paid by them. I'm not. But what's very cool is you can do this track mentored. And I am a mentor here. And what that means is once you submit the answer to the exercise, it goes into a queue, and a real human who knows how to program picks it up and gives you feedback on it. So that to me is a really, really excellent thing. So for this little problem here, this is the matrix problem. This requires you to make a little two-dimensional matrix. And they want you to write a class. And so if you see my solution here, you notice there's this thing here on line 9 that says class matrix. And so what this essentially means when the Python interpreter hits it is this is directions for how to make an object of type matrix. So how to make more matrices. And so it doesn't really do anything on its own until you call it and you say, hey, I want a matrix, and I want a matrix that, and if you look here, this special function that's called init takes self and takes a matrix string. You say, I want a matrix, I want it named Bethany's matrix, and you feed it a string. And the Python interpreter says, oh, you want an instance of the matrix class called Bethany's matrix. So I'm going to make you an object. I'm going to take the string and I'm going to run the following code on it. And then I'm going to give you back this thing called Bethany's matrix. And it's going to have a data member that is, and this is wading into deep territory here for people, so please stop me if your brain is full, because it's easy to overload on this. This is basically what's called a list comprehension. And so what you're going to get back is a list of lists. And you can tell that because there's 2 brackets here instead of 1. There's the outer bracket for the outer list, and then there is the inner bracket for the inner list. So it processes a string and it gives you back a list of lists. And that's its starting state. So this self here is basically telling the interpreter that when it makes a new type of matrix, every new matrix it makes requires a string, and it processes that string and has this thing called rows list that is a list of lists. And it travels around with that data. And you can do not anything you want, but you can do the following things with it. You can ask it for its rows, or you can ask it for its columns. You can't do much of anything else with it. But that's kind of and so if you notice, every single one of these has self as a keyword, because this doesn't mean anything unless you have the type matrix that you've made. So this belongs to this class, and it belongs to the objects that you make from this class. And it kind of doesn't belong anywhere else. So that's kind of the difference between that as opposed to if you go back, here's one here. This process is, oh no, that's another class. Sorry, that's an older version of that exercise. Let's go back to this one. So this 2 for exercise, this is just a function that will execute in the global scope, right? So it has a name. I mean, yeah, it has a name, and then it has a parameter, and then it returns something. And that's all. So Python happily runs these, but it runs these in what's called a global scope, as opposed to, when you do a class, anything that's inside the class is scoped to either the class or an object made from the class. So there you have it. But, that is, so if you're learning, Morgan, if you're learning OOP, one of the good exercises to do is to go through something like this or another small program, maybe even smaller than this, because this has some hairy code in it. Maybe just a little program that, asks somebody what their name and their age is and then gives it back to them. And write out, 2 or 3 functions to do that, and then go back and do the thought process about how you turn that into a class and why you would turn it into a class, and then turn it into a class and call it, make objects from it. That to me, at least that when I started learning how to do classes, that was the way I did it. I kind of backed into it. I'm like, so what about these functions belongs together? And what about what they do applies to an object? And kind of, went backwards into that. So I'm probably not going to be able to live debug this, but maybe I can walk through really quickly. This was kind of the first pass of what I did. So here you can see this is the little function that draws the board. And what you can see in here, this is a little feature of Python 3, 6, and above. These little doohickeys right here are called f-strings. And if you have taken any JavaScript or done any mail merges, actually is probably a familiar one as well. That's essentially what this is. So these little brackets here allow you to pop in code. And my friends hate me because I do crazy, I'm fascinated by f-strings and I put crazy code in there, and don't do that. Don't be me. I'm a bad girl. But what you can do is you can put variables inside here. So what makes this really nice is that, and they're called string literals for this reason, is that you can do things like put in variables without having to concatenate them. So normally, if I were to write this out, I would have to do something on the order of, and let me, I'll pull it up in my code editor. So I would have to do something on the order of, you know, if I were to make this without those, I would have to do and so this, just to explain this really quickly. So board is a list. And lists are ordered collections of things. And what that means is that they have an index. And so to get at an item on a list, you can refer to it by its index, which is what this is here. So I am asking for the contents of slot 1 in the list board. And so I think actually that this, I think you can get away with doing this because I think board is already a string. But then you have to concatenate it. And then I would have to do a string and the pipe and a thing, and then another concatenation and so on out. And so this can get sloppy. The other thing is that when you use a plus sign like this for concatenation, everything, all the types have to match or it tosses an error. So that can get pretty kind of long and kludgy looking. And Python, and there's actually a link in the repo to different ways to format strings in Python because there's like 5 at this point, which is a little bit annoying. But rather than do all of this rigmarole, it's easier if you're using Python 3.6 and above to just kind of do these little brackets so you can pop the variable straight into where it needs to be and you don't have to put the plus signs in there. So it makes it a little cleaner and easier to read. And then, you know, if you get more advanced with these F strings, you can actually do operations in them. So you can do things like multiply 2 numbers together and round it down to the nearest decimal point. And put that code directly into the place that it needs to be in the string rather than kind of hiding it somewhere else. So I'm kind of a big fan of these. So anyway, this is just, if you notice, a series of print statements for the board. And that's all this does. And that's kind of what you want with your functions, is that they do one thing cleanly and easily, if you can manage that. That's kind of a good rule of thumb. So here's another function here. This function is for the player to input the letter, if you saw that we did there. And this uses a special built-in method called input. In Python 2.7, and all the way up, I think, until 3.4 or something, there was like an input and a raw input, but when they rewrote Python for Python 3, they put it all into input. And so this basically directly passes whatever a user types on the command line into, it puts it into a string and it passes it directly back to your program. So if you notice here, I'm saving that into a variable called letter, and I'm also uppercasing it. But if you see up here above, I've also wrapped it in a while loop. And so this is a really kind of annoying thing. Unless it gets what it wants, it's just going to keep asking you. It's an endless loop until it gets what it wants. And then what I've also done is I'm stashing this in a data structure called a tuple. So tuples, like lists, are ordered, but unlike lists, once you've made a tuple, you can't change it. So it's kind of like a string. If you want to change it, you have to make a whole copy of it. You can't replace this X or this O once it's in there. So the advantage to that is that stashing something in a tuple and then getting it back out again makes it fast because it never grows, it never changes. So they're kind of handy that way. The downside is that if you put something in a tuple and then you realize that you have to update it, it's a pain in the ass. But so anyway, so this function has two different returns, right? If it's one, it has one thing, and if it's the other, it has the other thing, the if else sort of thing. And we go down to the first move, and so here's where we're using random. And if you, so random.randint, so basically randint takes two, well, not two, it takes a n length list, so however many, but then it will choose at random from them. And so this one, it only has two. All right. And then here's a play again. This one's probably too small, but we put it in there. Again, this one as well, the make move, it probably can be combined with something else. I mean, one action and a function is a little extreme, but essentially what it's doing here, again, board is a list. Move is a variable, it's an input parameter, right? And so this is a number 1 through 9. And so basically it's saying, write the letter into the position that move represents. And then this is what you call when you're trying to figure out who's won. So if you picture, and if you look at the trinket on the right-hand side, there are messages, status messages that we're printing out that kind of show you what's going on here. But essentially, if you pass in that list and the letter X or O to this function, it's going to check to see which slots are occupied, right? So if it's across the bottom, so you want to check 7, you want to check 8, and you want to check 9. And so these are all of those conditions for that. And here's our famous board copy. Yeah, not sure that really needs to happen. Because essentially what you can do here is this. And that's duplicated it. You don't need the loop. And then once you've got it down to one line, you probably don't need the function. This is something called slice notation. We also have an exercise around that. And slice notation is really, really handy in Python. So when you do something like this, and it's really start, stop, step. I think I'm going to take a pause here and pull up that exercise. So slicing. So basically what this allows you to do is to take a piece of something and do what the word says. Chop it off from one piece to one piece. And so you can take different slices. But if you don't specify a start and a stop, Python defaults to just handing you back a copy. So you can call copy on something. You can do this, which is go through the whole thing and copy each item one by one and append it to a new list. Or you can do a list slice, which has the same, essentially the same functionality. You have to be a little bit careful. You'll discover this later down the road, that sometimes you need to do more than just what's called a light copy. You need to do a deep copy. But that's sort of an edge case. For all intents and purposes, if you do something like this, that's enough to make a copy. You don't need to do this rigmarole. This is more as an example of what's happening behind the scenes. This is what Python does under the covers when you call copy. All right, so is space free? True or false if the item is empty? Get player move. Okay, so this are the potential moves. And then basically what this is doing is not letting you choose a number that isn't free. And so it's just going to continue to nag you about what your move is. It's going to ask you what your move is. Once it finds a move that's acceptable, then it's going to return that number for you so that you can use it elsewhere. This is a little function for the quote unquote AI that runs the TicTacToe game. So this is letting you choose a random move from a moves list and a given board list. So what this is doing here, if you see, this is a for loop. For every item that shows up in the moves list, it calls, is the space free? If it is, then it's a possible move. Once it's done with that and assembled the moves list, then if there's a move in the moves list, choose one at random. Otherwise, don't choose anything because you can't. All right, now we get down to what the computer is doing when it's playing against you. So we know the human gets to pick something. The human can see what's going on. The computer is doing something a little bit different here. So this is just establishing who has which letter. And then this is the little quote unquote algorithm. So basically, it's going through a for loop, and it's 1 through 10, which is really, this range is a really interesting thing. So if you've taken C, C++, JavaScript, Java, or not, usually what you see is this whole counter thing where you set up a variable, and every time you go through the loop, you add one to the variable until you get to however many loops you want. And that's a perfectly great way of doing it. But Python, the makers of Python being the wonderful lazy people that they are, yay, has created this special thing called range. So when you call range, it returns this thing called an iterator. It returns basically an internal counter. And so range will basically go through as many cycles as you specify. So you do a start, a stop, and a step. There's one catch to this, which is that in Python, ranges usually start at 0, as does indexing on lists, but the end of the range is excluded. So basically, this is going through positions 1 through 9. That's always driven me crazy about Python. So you have to subtract 1 off of whatever the end, or add 1 to whatever it is to get the full. So if I didn't want this to start at 1 and I wanted it to start at 0, I could just omit this. And if I do this, then this loop is going to go from 0 to 9. But I wanted it to start at position 1. For the sake of kind of sanity, the board for this tic-tac-toe game has 10 slots, and then the first one is purposely blank so that you don't have to keep mentally saying, okay, 0 is 1 and 1 is 2, because it's really confusing when you're drawing the board. So yeah, but normally you would just put range 10 and you would know that that went 9 times, or you'd put range 100 and you'd know it would go 99. And then if you did this, it would only do every other one, which would actually be, what, 8? No, not 8, excuse me, 4. Yeah, math is fun. Okay, so so essentially what this is saying is you don't have to name this. I always like to name mine because it just helps me read the code and understand what's going on. So I named this number. But this variable here can be anything, or what you might see in some code is this. And basically what an underscore tells the Python interpreter is, I don't really even need to do anything with that, so I'm not even going to name it. I'm just going to, you know, put an underscore there. I just want you to rotate 9 times and be done with it. But I always like to do this just in case I need to refer to it. So anyway, for this 9 times, it's going to copy the board, check if there's this, if in that board copy that number is free. If it is, make the move with that number. And if that results in a win, then that's the number we want. So this is all kind of theoretical. It's going to try every single option until it comes up with one that potentially works as a win. So it always wants to go for a win. So this is step number 1, tries to win. Step number 2, checks to see if the player can win in their next move. And if that's true, then take it away from them. Because, you know, we're 5 and that's how we play. So that's the next step, right? If I can win, then I'm going to go for it. If you can win, I'm going to try to stop you from winning. So then we go to step 3. If all else fails, take a corner, because that's a good position to be in, is to take a corner. So return that one if that works. If that doesn't work, try to take the center. And if all else fails, well, take one of the sides, right? It's the only thing left, so why not? Here, checking to see if the board's full. Okay, so these are all the things that you can do if you call them by name. But we have yet to actually execute any of this code. So then if you start to scroll down to the bottom, you'll see, starting on line 158, this is where we start executing code when the program runs. And here, at line 162, is where we start our main game loop. So you start here, you reset the board. You set up a new board that's empty. Then you ask the player for their letter. And then you call first move to figure out who gets to go first. You print that out. Notice here, it's the turn. Turn is equal to whatever the first move function returns to you. And if you remember, first move up there did a random choice between one or the other. And then you set this variable called game is playing true. Why? Because you keep going while true. Okay, so now at 170, we have the play loop. So this is the whole loop for the whole program. Yes or no, continue to play. This is for this particular game. So while the game is playing, whoops, Bethany, don't type any spelling errors. If it's the player's turn, draw the board, get the player's move, make the player's move. If the player wins, draw the board, print hooray, you won the game, and set the game is playing to false. Or check if the board's full, and if it's a draw, and print the game as a tie, break out of the loop, and ask if they want to play again. Otherwise, right, so if you're not a winner or the board isn't full, then the turn gets to go to the computer. So that's inside this while loop. Then, actually, we're still inside the while loop, excuse me. So that's player, but now it's not the player because it's the computer. We do this. The move equals the computer's move, and the computer makes a move, and then we check to see if the computer is a winner or if the board is full. If all else fails, the turn goes back to the player. So that's the playing loop. And then the outer loop, as long as you say play again, you continue. But if you say, no, I don't want to play again, then thank you for playing. You break out of the whole thing. This is false, and you're done with the game. So I think I'll pause here and see if there's any questions. Yeah, we'll go from there. And I think we probably need to talk about whether or not we want to do more of this because we're running late on time, or whether you guys just want to clone this repo and kind of explore the exercises and the steps and the refactoring yourselves. I'm always happy to answer any questions kind of asynchronously on Slack, or we can also, if this feels like it's engaging, we can always schedule another follow-up session and kind of dig into this a little bit more and really walk through kind of the data structures and the other things that were used to put this together. So yeah, I want to ask if you guys have any questions and kind of some feedback on how you kind of want to proceed from here, because ultimately it would be great if we could get you writing some code. So. Oh, do I need to unmute people here? Happy to answer questions via chat, or if you guys want to unmute your microphones and
there we go. It's not muted anymore. The only thing I could think to ask is why not use classes, but then I thought maybe this was just for the sake of a beginner tutorial type thing.
It is exactly for the sake of a beginner tutorial type thing. You probably would want to use a class here, and one of the classic ways to pull this apart, and I won't go into it too deeply because classes are a little bit intimidating at first, I think. But a classic way to pull this apart is to have one class be for the board, and then you have a class that represents, you know, the player. Although you're playing against the computer, so you may not want to do that. And then you have, you know, your outer game loop, basically. And you call the loop, and then you instantiate a board, or you might have a class that refers to a game. That may be a better thing in this circumstance, right? Because the game has the score associated with it, and it has players associated with it, and do it that way. And I have a blackjack game if we decide we want to do an ongoing series where I've done exactly that, where you essentially have like the blackjack board, and then you have a different class that refers to different kinds of players, and that those players have internal scores that they keep, right? How many chips they have, how many cards they have, that sort of thing, and model it that way. But yes, for the sake of, you know, kind of getting people's feet wet with their first program and working up a logic, it kind of felt like putting a class on top of the whole thing. It's more to dig through, right?
Yeah.
Yeah. And the core logic is kind of the same. Anyway, I'm sorry, I interrupted you. Go ahead.
No, it's fine. I hope I'm not like keeping anybody else from asking questions. But the copy for the board, that's to update the board with new information, correct?
Actually, if you look at that, that isn't to update the board. What he's trying to do there, and I say he because I did borrow this code from in its original state. I borrowed pieces of this code from the guy who wrote Automate the Boring Stuff with Python. He has another book called Invent with Python, where he goes over his version of this tic-tac-toe game. And I did change some of it for my coding style, mostly in the refactor, but I did start with his core concept. And I think the thought there was here, if you look at this for loop, so you have to have a way for the computer to test whether or not the board's going to be a winner to figure out the next move. If you were just doing this where I'm playing against you, then we wouldn't necessarily need to do this. But here, you don't want this to update your board unless it's a winning move, right? So the computer needs to make a copy of the board so that it can check to see what its next move is, basically. Which is why I said it's a little extreme, because you could have just here done this, and then you don't need the function. And really, you know, that function is not necessarily useful anywhere else because Python has a built-in copy. But I think he was really doing that to kind of show that that's kind of your thought process behind functions. You want pieces of code that do one thing fairly well that you can reuse in other parts of your program. But yeah, here I think it's just as easy to copy the board that way. But then of course you have to, you know, you have to go down the line and pass it in. So yeah, but if you look at, let me see if I have the other one up here. For the one with the GUI, I do call update for that. Although I am still internally tracking, let's see what I did for the algorithm here. So there's a lot of, you'll find this out when you start working with the turtle. There's a lot of coordinates in here that you have to measure, which is why this program is now 4 times longer than it is for the command line. Let me find the. Alrighty. Sorry. Okay, here. Yeah, so for what I did, I eliminated that function. And I just copied the board. And I am also using, so this is the other thing that is a little bit funky about not putting things in classes. I am using what are called global variables. So global variables are variables that are in the outermost scope for Python. And the way this works is there are global variables, which are available to anything at any time as long as the Python interpreter is running. And then one down from that are class variables, which anytime you instantiate a class, they're available to anything that interacts with that class. And then down one more are variables that are in function scope. And the variables that are available inside of a function, unless you explicitly pass them out of the function, they are, quote, out of scope. They go out of scope as soon as the interpreter passes by the function. So that's why you get something like needing a return statement in a function, because if I want this number, this thing called number, and I want to use it outside the function, I have to pass it out. If I don't pass it out, it ceases to exist once this function stops executing. Well, long-winded thing. So essentially, what you're referring to, Morgan, about updating the board, because these variables are in global scope, basically they're getting updated when you assign to them, because they're kind of available to anything, anytime. Now, that only is a good idea when you're first starting out and making small programs. It is generally a very bad idea to use global variables because they're available to anyone at any time and at all times. So if my code is using it and updating it and your code expects it to be a certain value, well, we got a problem. So generally, the use of global variables is discouraged, but they are very, very handy when you're doing small scripts like this and when you're first starting out, so that you have a place to kind of park things. But typically, what you do, as you described, is you'd enclose this in a class, and what you'd be updating would be the data member that belongs to the object. And so that scope would stay with the object. And in order to get at it, you'd have to ask the object for it, or you'd have to access the object. And it's a way of encapsulating it so that nobody can change it out from underneath you. But since we know this, the only thing running in this universe for this little script is this TicTacToe game, we can totally get away with it here. All right, I've rambled on enough. Anybody have any more questions? I'm happy to answer any of them. I did have a whole bunch of warm-up exercises planned, but I think we are running a little short on time. We've got about 20 minutes left. So I don't know if we want to plan out stuff, or if you'd rather just pull this stuff apart and work on it and check in with questions, or how we want to proceed.
I don't really know what would be best. I'm fine with anything.
Anyone else want to weigh in? Questions? Thoughts? We got a very quiet group here. I don't know if I need to unmute people or what we need to do. Oh, link for the code? Yeah, it's right up there under the link. There we go. Thank you for reposting, whoever did that. So the trinket is kind of an interactive little thing. You should be able to play with the code in that and then rerun it and play around with it that way. Or you can fork it. Now, forking it may require that you sign up for a free account at Trinket. But it's pretty fun. And they have other little things that you can do and you can play with. But that code that is in the Trinket is also, I believe the file is called turtle, TicTacToe add turtle. So you can also run that, the TicTacToe add turtle file if you have an installation of Python 3.6 or above. And you want to make sure that it's 3.6 because I've used f-strings. So even though the Python turtle module has not really been updated since I think version 3.3, because I've used f-strings inside the file, if you try to run it on a version lower than Python 3.6, it's gonna whine about unexpected input because it doesn't understand what these f-strings are. So if you have Python 3.6, 3.7, 3.8, you should be able to just take this file and run it on your machine. And it will actually pop up a little, let me see if I can, I think this is set up correctly. Maybe not. It seems to have a problem with this file. So unfortunately, I'm not going to be able to run it from PyCharm. But it should pop up a little window for you. Actually, this is annoying me. I'm going to close this really quick, and I'm going to open it up again. All right. Nope, PyCharm is really just giving me the finger. Anyway, it essentially opens up a little window for you that it should, I tested it on my Windows install and I tested it on my Mac. I'm not going to make any promises on Linux, but I'm fairly confident it'll work. And it just opens up a little window and lets you do that same interactive thing that you're doing with Trinket. And you don't need Pygame. Turtle is part of core Python, and the libraries that support it are part of core Python. You do need to import the module, but beyond that, it should work fine to do it that way. So, note to self, get my PyCharm unscrewed up. Oh well. But yeah, the turtle is, I don't know. I kind of went down a rabbit hole with turtle. I enjoy turtle. Oh, also there are links in the repo to, let me see if I can pull it up here really quick. Under the drawing figures with turtle, you will see that there are links to both Trinket and also REPL IT. And REPL IT, I don't think requires you to have an account to do stuff with. So for instance, there is, and this was made by one of our community members, Sarah, who's amazing. And she made this little rotating squares thing. And actually I've changed the angle so it's no longer, oh, this one's the growing triangle. So this one does triangles and a star, which is kind of cool. And you can play with the angle of it. And actually you can make different shapes if you play with the angle of it, which is kind of fun. So it gives you a little bit of an idea of how the turtle works, so that in case you wanted to, I don't know, draw different things than X's and O's for your tic-tac-toe, or wanted to make a checkers board instead, you could do that instead of doing tic-tac-toe. It's essentially the same logic, although you would want to, you know, of course, change it because checkers allows you to do jumps and different things. So yeah, and then there's so this REPL. This is the one that does, yeah, this does the rotating squares. Although you can also do rotating triangles or rotating stars. So that's very fun. Just because I'm easily amused. But it is quite fun. And I also, if we do more of these, there is also a spirograph program that will draw different things. Oh, except that this is the lame one. So it'll draw different designs and different things like that. So yeah, I think I'm going to pause here and, ask you guys for a little bit of feedback and for some thoughts on this. And try to assess if we want to do any further of these or if we want to think about different ways of doing a project. But yeah, so I think that's all I really have for now. I mean, there are a lot of exercises and a lot of information here, but as I said, we're kind of running down to the last 15 minutes. So.
Yeah, this was really amazing. Thank you, Bethany, for sharing your time with us. If you guys want to take a few minutes to think about it or take a few days to think about it, feel free to join us in Slack. If you haven't already joined, just go ahead and email us at python@womenwhocode.com. We'll get you an invite link, or if you wouldn't mind, we can just use the emails that you signed up with here, and we can send you invite links that way. It looks like there's a comment. Someone says program has a glitch from multiple clicks before the computer's next turn.
Okay. Yes, it does. And so if you can figure out how to solve that bug, awesome. Yeah, if you click too quick, the turtle loses its position.
So good find.
Yeah, good for you.
But yeah, I think now's a good time to go ahead and end it. We do have another study group or a study group later tonight. If you're new to Python, it's automate the boring stuff like Bethany mentioned earlier. If you want to follow along, we're on chapter 2 this evening. There's a new webinar Zoom link for that. So again, if you need that, just link your email address here and we'll shoot you an email with that invite link. But yeah, if there's any other questions or feedback, feel free to let us know. Again, the email is python@womenwhocode.com. And again, Bethany, thank you so very much.
Oh, you're welcome. And I am happy to answer any follow-up questions, either about the exercises or about the program, or about Python in general. We all hang out in Women Who Code Python in Slack. Yeah, and I'm happy to interact and do all of that sort of stuff. So